Welcome to my class of Kinematics Problems. Here we can start with the question to find average speed and average velocity. The question is that Sam swims 3 laps of a 25-meter pool in 120 seconds, starting from one end P and swimming towards the other end Q. So he starts from P and ends in Q. So this is P and this is Q. But he took 3 laps. So there will be, this is the first lap. And this is the second lap and this one is the third lap. So this is the part that is taken by Sam. So in order to find the average speed, we have the equation speed average is equal to distance over delta t. Here the distance traveled, here one path or the length of one path is 25 meters. So he took 3 laps. As it is 3 laps, the total distance is 3 into 25, which is 75 meters. And time also will be like the time. He took only 120 seconds, so time here is taken is 120 seconds. Substituting these values in equation number 1, we get speed is equal to distance over time, that is 75 over 120, which is equal to 0.625 meters per second. Second part of the question is about Sam's average velocity. So average velocity can be calculated from the equation displacement over time. Here, earlier it was speed, so it was distance. So we used equation distance over time. Here is velocity, so we need to use displacement over time. So the path taken by Sam is given here in this diagram. So the initial position was at P. Initial position was at P and final position was at Q. So the displacement is obtained by change in position. That is final position minus initial position. So that will be like final position. He is only at 25 meters away from the initial position. So it is 25 minus 0, which is 25 meters. Now average, the time taken by the Sam is again, T is again the same 120 seconds. So displacement is 25 over 120, which is equal to 0.21 meter per second. Sunny is running a sprint race. He starts standing still and speeds up at a constant rate over the first 4 seconds to reach a velocity of 11 meters per second. He maintains this velocity for 7 seconds and then, having run out of energy, slows down at a constant rate over the next 3 seconds to a velocity of 7 meters per second as he crosses the line. So, here Sunny is running a sprint race where he starts still and from here it starts still and he speeds up at a constant rate over the first 4 seconds and reaches a velocity of 11 meters per second. So first 4 seconds he starts from 0 to 11 meters per second. Then from there onwards, he maintains this velocity 11 meters per second. He maintains this velocity for 7 seconds. This 11 meters per second was maintained for 7 seconds. Next 7 seconds, it was 11 meters per second. Then he ran out of energy and slows down at a constant rate over the next 3 seconds. So next 3 seconds. So he started, reached 11 meters per second and maintained 11 meters per second here in this area from here to here, and then he reduces from 11 meters per second to 0. So there are 3 areas. This is for calculate his acceleration for the first 4 seconds. So this is A. Calculate his acceleration for middle 7 seconds. This is B. And calculate his acceleration for final 3 seconds. This is C. So let us do the calculation. Hope you have understood it. In this first part, the initial velocity was 0, or he started from rest and he reached a final velocity of 11 meters per second. So final velocity is 11 meters per second. So acceleration equation is change in velocity over time. So average acceleration is change in velocity over time. For the part A, we have already seen that. For the part A, the final velocity is 11 and initial is 0 and time is 4 seconds. So substituting that, we get final velocity minus initial velocity over change in time. So final velocity was 11 meters per second minus initial was 0 meters per second over time was 4 seconds, where the answer is 2.8 meters per second. Now, the second part, he maintained a constant velocity. See, he maintains this velocity for 7 seconds. That is, there is no change in velocity during the second part of his motion. So during this second part, initial was also 11, final was also 11, and the time was 7 seconds. So B, the average acceleration, A average is equal to delta V over delta T, where there is no change. Initial and final was 11 meter per second minus 11 meter per second over 7 seconds, which was 0. The third part is calculate acceleration for the final 3 seconds. For the final 3 seconds, the final velocity was 7 meter per second as he crosses the line. So this is 7 meter per second. So final velocity is 7 meter per second, initial velocity is 11 meter per second, and change in time is 3 seconds. Using the equation for average acceleration, we can find the value by substituting the values of velocities, which is 7 meter per second minus 11, which is minus 4 over 3, which is minus 1.3 meter per second square. This means that he has been reducing his speed or decelerating. So we have seen two problems. One was to find the average speed, and the second part of that was to find the average velocity. Third one was about average acceleration. So we are here to solve the problems in kinematics. We just started looking into the initial part of the kinematics. Thank you for watching.